Alright, here we go. So, I'm going to write my game library once again. Current state is like kinda good, kinda not. Like, it almost works. Anyway, as far as I understand, like the main problem is game logic, like not library logic, so I don't think I have to fix that, right? Anyway, today I plan to create Conway's Game of Life, right? Use everything I have already written to create some minimal game, right? But first of all, I have to do it most everything here in the main function. Okay. Terminal size, yeah, I need that. Frame time, milliseconds. Okay. Canvas, right, terminal. Last frame time, okay. And here, now, delta, last frame time, delta, player pause. Okay, I don't need this. Roll with. It's actually interesting. Let it be screen size for now. Delete this. This. Yeah, good enough for now. Actually, I don't need delta S anymore, right? What do I? Yeah, it's not. I'm gonna like. I'll use frame rate as a speed of generation, right? So the next generation is gonna be every one frame rate, every next frame, and changing the frame rate will change the speed of the game. Okay. So what are we doing here? Let's create struct const cellular something like that. Struct cells. Okay, it's gonna be a list, right? std mem array list. How do I do that? std array list. Oh, okay. Never mind. It's not mem. Array list. Type bool, I guess, right? Then I guess it's good enough for now, right? Yep. Actually, I probably need two of them, right? I also need next. Cells next. So that. Can I do type of cells? Will it work? Oh, it works. No way. Interesting. Okay. Then public function. How do I call it? Next generation. I need self. How do I define self? It was here somewhere. Yeah, so we just add this. Okay. It's const self, this. Okay. Mm-hmm. Okay. I'm taking pointer to self. Okay, then. I guess that's it. Nothing, right? Alright. And we'll return void. Let's go. Sell that sells. Okay, there are gonna be some rules, right? There should be some rules. So it's gonna be a function. Called seller automaton. Well, we can call it just. I'm not sure how is it correctly to call it. Mm-hmm. And here we'll return struct. So I can create different variations, right? One of which is gonna be game of life. Turn. Type, it's type, right? Huh? Expected comma after parameter? Is it because it should be here? No, it's not. Self. Oh, because yeah, it's column. Star self. I need rules. So here are gonna be rules. Okay, first of all, I have to do some research. How do I define rules? Rules. One of these rules shows that one is restoring complete. Rule 110. So elementary solar automaton. Can I like do they have page for solar automaton rules? Rules editor. In mathematics and computability theory, an elementary solar automaton is one-dimensional solar automaton where there are two possible states. Okay, that's not what I want actually. I want two-dimensional. Rule. Rule table. For each of the 512 possible patterns, the rule table would state whether the cell. Okay, rule table. There's only one mention. Okay, let's just go through it. Oh, classification. Wolfram's classification was an attempt to classify the rules themselves in order of complexity. This are class 1 your own show. Is that what I want? It's actually not what I want. Also, I want it to be dark. Full study. Current pattern. New state. Full center cell. Huh. Also, it's like a line, right? But I need two-dimensional pattern. Full space. Okay, but it's elementary automaton. Physics, computer science. Okay, you know what? It's probably gonna be Convex Game of Life. Rules. The universe of the Game of Life is an infinite two-dimensional orthogonal grid of square. Okay, of square cells, each of which is in one of two possible states: live or dead, life or dead, or populated and unpopulated, respectively. Every cell attracts. Okay. At each step in time, the following transition occur. Any live cell with fewer than two. Okay, I understand, but what is like the most efficient way to represent these rules? Yeah, born 1, survive 1, 2. So I have like to make two arrays, right? For amount of cells for another to be born or survive. Okay. Rules. Also, I can do it in one table, right? In one array. Survive. Life rule. It's gonna be slice of 8. Oh, but what if I want to have more than 8? I guess that's a problem for future me. Is it 8? Yeah, it's 8. Bulls. Born rule. Bull. Yeah, good enough now. Wife rule. Actually, it's gonna be const. Okay. Declaration, survival rule, shadows, function parameter from other scope. Okay, and so what can I do about that? If it has to have the same name. Can I do it like shadows still? Okay. Survive, burn. We're going through each cell. Cells. Oh, we have. I also need index, right? There's also size. But it's gonna be dynamic actually, you know. With 16, height 16. How do I increase the dimensions? Like, I'm using one-dimensional array to represent two-dimensional matrix, right? And I have to somehow expand it. So I have to move the lines. Probably, yeah. So increasing the size is probably gonna be expensive. Anyway, let's make it static for now, right? Don't think about that. I'm going through each self. I need a way to index scenes, right? Wait a minute. I feel like I'm gonna use it a lot and I probably have to create an abstraction on top of it. Two-dimensional array list ZIG. Curious. I looked through the documentation, but I can't seem to find any reference on how to define and initialize multidimensional arrays in arrays of strings. Is it supported, and so how I do this? Huh? Just keep reading each as array of and you already have it, okay. Brackets T is a slice, not an array. A slice is a pointer and a len. Multidimensional array looks like an empty. Okay, I'll leave this issue open and add multidimensional array examples to the docs. Okay. Okay, let's keep it simple then. Width is 16, height is 16, right? Well, it doesn't matter actually. Oh, I want. Okay, let's keep it that way. Let's keep it that way. Going through each cell, I need a way to index them. Let's just copy it for now. Okay, self, x, y, self, cells. Okay, what if index is out of bounds? I have to wrap it, I have to make a torus, right? So the world is gonna be a torus, where all edges are connected. How do I do that? If y is less than 0. Actually, I can do it without is, right? Const y equals. Okay, y is constant by default, right? I can change that. Can I? New y wrapped, it's gonna be wrapped y const, and it's y plus height modulo what? Height, I guess. Height. Okay, it should work actually. Use of undeclared and then fire height. Okay, self.height. Should work, right? So if it's in range, it's just gonna add height and remove height. If it's less than range, it's gonna push it in range and then it will just stay like on the other side, right? So if it's 1 and height is 10, or if it's -1 and height is 10, it's gonna become 9, right? And the same thing, if it's bigger, it will just remove the height. It won't work if, like, it's gonna be much less than our range, but it's not a problem for now, actually. At X. So with. Oh, my bad. It's gonna be wrapped Y and wrapped X. Okay, we have index now. It will return, actually, what the hell is that? It should return ball. Mm-hmm. Mm-hmm. For cell.cells. Again in cell. Oh, how will I know, like, where this cell is? I have to do reverse index, right? But I can index them using this, right? Okay. Again, each cell, we have to know its index. So we're doing the same thing, but other way around. Reverse index. Oh, it has to be. It has to be camel case, right? I'm still confused about conventions. ZIG naming conventions. ZIG naming conventions. Type and namespaces. If X is a type, then X should be title case. Okay. The first part of this guideline is straightforward, and similar conventions are found in languages like C, C++, Rust, and Java. Non-primitive types in ZIG like struct, union, enum, and arrow should be written in title case. Okay. Here point, color, data, and file. Okay. Title case names are also used for function parameters and variables that store types. Title case names are also used for function parameters. Huh? Wait, key? And variables that store types. Returns what the hell is it? Signedness of an integer type. Oh, wait, signedness. This is like a sign. Signedness in computing. Signedness is a property of data types representing numbers in computer programs. Is a property of data types representing numbers in computer programs. Huh? A numeric variable is signed if it can represent both. Okay. Okay, so signed int because it stores type. Makes sense. Okay. Okay. So every type is title case. Okay. ZIG's import button function imports the public declarations from another file wrapped in struct. ZIG source files are implicitly structs with no fields. Okay, because these structs have 0 fields and cannot be initialized, they are treated as namespaces and are written in snake case. Here's a file example. Huh? because these structs have 0 fields and cannot be instantated. How do I read that? Insane. Translate.google.com. Instantiated. Insane. Okay, instantiated. We'll keep that in mind. They're treated as namespaces and are written in snake case. Here's the example. Add one. Function. Okay. Okay. What about methods? Point. Like, I need something simpler, you know? I don't see methods. Come on. Start guide. Roughly speaking, camel case, function name, title case, type name, snake case, variable name. Okay, nice. If X is a type, then X should be title case, unless it is a struct with 0 fields and is never meant to be, instantiated. In which case, it is considered to be a namespace and uses snake case. If X is callable and X returns type, then X should be title case, because it's pretty much type. If X is otherwise callable, then X should be camel case. Okay, otherwise X should be snake case. Okay. So all functions are camel case, and it doesn't matter if it method or not. Reverse index. Index U64. X, Y. How do I return point, right? I return vec to you. Const. Come on, const vec to U16. It looks ugly. Is there a way to fix that? Like, it looks really ugly. And I can't have generic vector, right? I just can't do that. ZIG generic vector type. And ZIG generic. Int array. Len, yeah. Yeah, so that's the limit. Okay. I mean, kind of obvious. I should call it E16 vec2. E16. Okay, let's just leave it that way. Vec2. E16. Let's get back. Here. Vec2 E16. Index is probably gonna fit. Oh, it's usize, right? Because it's index. Then we're going to index. It's X, right? So it's modulo with self.with. Huh? Index. Function parameter shadows declaration of index. But it's like, huh? Oh, is it because of this one? Okay. Let's keep an eye. And y is gonna be divided by self.height. No, it's self.with still. Okay. and we return struct vec to a16 x.y. Can I do it that way? No, I can't. I have to, yeah, x y equals y. Okay. What we're doing here? I don't actually need this one, right? I just need index I self.reverse index I pos const position, then you should calculate amount of neighbors, right? Alive neighbors const alive, oh, it's variable, it's var alive neighbors. Is it how you write neighbor? Yep. Neighbor? Get me back. 0. And it's like, I don't know. Okay, so U1 is 2 numbers. U2 is 4, it should be U3, right? For how do I do that? Const neighbor add. Yeah, I have add here. Okay, I can use it. Neighbor shifts. Should be an array of vec 2 a16, I guess. Then I create array here with x equals -1 dot y equals -1 2. Oh, seriously? Okay. 3, 4, 5, 6, 7, 8, 9. Oh, why 9? 8. Then we're going here. No, then it's x equals 0. Then it's x equals 1. Then we're going to y 0. It's -1 and 1. And then y -1, and it's going to be 0 here and 1 here. Then we're going through all the neighbor shifts. Shift. Alive neighbors. If pause add shift. So we got the pause, right? We have self index. Okay, I have to remove that. Paste it here. Const shifted. Come on, just can you format it, please? Then we are doing index of shifted.x and shifted.y. Then we're doing alive neighbors plus equal 1. Yeah, looks good to me. Okay, now we got neighbors. Then we have to watch the table, right? How do we do that? Okay, cell can be either alive or dead, right? And we can either make it born or survive. Okay, so there are four conditions, right? The cell is already alive and we keep it alive. The cell is alive but we kill it. And other way around, so cell is killed but we keep it killed, and cell is killed but we make it alive. But I can check for 3 of them, right? Damn, it's so hard to think. Okay. I got the amount of live neighbors. We're going self. Not here. Self dot survive, I guess. Can I? I can't. Can't survive. Self dot survive. Huh? Wait a minute. Can't survive. Survival. Yeah. Why doesn't it work for me? If alive neighbors. Oh, can I? Like, how do I array contain? Array contains ZIG. I think that it's generally the most automatic solution. It is possible to use contains, at least from a CDMM, but this seems like an abuse of that function, just really for finding sequences. Okay. So I have to just like do the for loop. Okay. That's it. For self dot, where am I? Self dot survive. Why I can't get? Is it because it's small error? Oh, it should be public. I don't know. Pub const. Probably, yeah. That might be the reason. Self dot survive. No, it's not. Insane. Self dot survive. And yes, capture. Amount. If live neighbors equals amount. Okay, it doesn't matter if it's live neighbors. We don't check if it is alive or not, right? If it's a live rule, it's not. If it's not survive, but okay, if it's survive, we have to check if it's dead. Yep. So it's cell state, and can I do is? No, there's no is. Then what we're doing, self dot next, self cells next dot index. Oh, it should be, it actually should be a pointer, right? Yep. Self index. Okay. Index. Where do I get? I got pos, right? Pos x, pos y. Star equals what? True. Okay, let's move on. Copy. Born. It's called born, right? Yeah, born. Amount. If life neighbors equals amount. Just. Okay, here I have to do continue, right? Not continue, wait. Break. Actually, I can do that. If continue. Come on, can you just format it, please, please, just format it. Okay. Looks good to me. Then this loop, right? After going through everything, I have to swap them, so cells equals self dot cells equals self dot cells next. Yeah. And then self dot cells next should be empty. How do I do that? It's a list, right? Why don't I have any suggestions? It's so weird. Okay, here I have. Is it because type of? Array list. Bool. Oh, STD. So what's next? Capacity items at many. Can I replace them? Like, clean it. Fully clean it. I've done it already, right? At some point. Terminal. Buffer writer. Print. Previous canvas pixels replace range. Okay. Okay, so it's replace range. Place range. 0. Wait a minute. Oh no, it's not what I need. Actually, no. Actually, it's not what I need. What's buffer? Probably buffer. Buffer the init. Clear retaining capacity. K, right? It's capital K. Invalidates all element pointers. ZIG clean array array list with 0 values. Append times. Capacity. Okay, it's append times, right? But I'll have to... Also, I have to invalidate them, right? Capacity is gonna stay the same. Clear and free. Retaining capacity. So, does capacity stay the same? Replace range, replace assume capacity. Needs capacity size, okay size. Add many as array. But it said resize the array. Yeah, it's not what I want. Add a new n elements which have undefined values. No. Assume capacity. Append. Extends the list by one element. Allocates more memory is necessary. Invalidates element. Pointers if additional memory is needed. Okay. Append times. Yeah, but first we'll have to clean it, right? Clear and free. Replace range. Swap remove. Oh, it's only one. Okay, let's clear it. Not clear and free actually. Clear retaining capacity. Self.cells. But next append and times. Value false. Self dot cells next dot capacity. I hope it works. Okay, I have two errors. They're here. I also need init. Public function init. Return self. With paid. Turn self. Cells. Canvas. Array list init capacity. Append times. Okay. So that's how we do that. How we are doing that, right? There's it. But what if I'll bow Expand and times. False. Capacity. Will it work that way? Okay, no, it will not. Cells. Okay, actually, dot capacity is like insanely convenient. I mean, assume it works, right? Cells. Oh, my bad. What am I doing wrong? Oh, it's equal, not... Okay. Const. Locator. Locator. It's std mem allocator, right? std mem allocator, yep. Where was I? cd.mem.allocator. Allocator, not allocator. Or is it allocator? I don't know actually. Array capacity. Dot capacity. It's so cool. It's so cool. And I probably can just do that. Yep, nice. With hate cells. And do the same here. Okay. Here we go. I got init. No. I shouldn't need that. First of all, game of life. Oh, it's a variable of life. No, it's a type. It's a type. Game of life equals cellular automaton. Bool. What are the rules? Any live cell with fewer than 2 life neighbors dies as if other population with fewer than 2 life neighbors. So survive is gonna be 3, 4, 5, 6, 7, and 8. Any leaf cell with 2 or 3 life neighbors leaves to the next generation. With 2 or 3. Okay, so it's only 2 or 3. Wait a minute. I will just read it as a life. I don't know how to life leaf. Any life cell with fewer than 2 life neighbors dies. Fewer than 2, so it's only 1. Is there a 2? It's okay. It's 2 and 3. Any life cell with 2 or 3 life neighbors leaves. It's probably leaves. It can be lives. It leaves. So this one leave 2. Any leaf cell. Live. Okay, but what if I'll take the sentence?
Any live cell with 2 or 3 live neighbors lives on to the
Okay, so it's life and leaves. Okay, insane. Any live cell with more than 3 live neighbors dies. As if by overpopulation. Okay, makes sense. Any dead cell with exactly 3 live neighbors becomes a live cell. Okay, so it's 2, 3, and 3 rule, right? 8, bull, 3. Const game equals game of life dot init allocator with height. Okay, we got game, but I also have to print it somewhere, right? Not just calculate everything. How do I do that? I can just access cells, right? Is it public by default? Game.cells. Yeah, I can access it. Can I make it private? I can't, right? It's impossible to make them private, seriously? Oh, ZIG, private struct fields. Always public by design. Private fields. Okay, ZIG works. Private struct fields. Speaking of struct fields, they're always public. Structures and functions are private by default, with an option to make them public, but struct fields can only be public. The recommendation is to document allowed proper usage of each field. Seriously? Why so? I don't want to editorialize this post too much, but it's already caused the type of issues that you expect that I think it only caused more difficulties in 1.x world. Okay. Let's read the issue actually. Not planned. Not planned. Andrew Kelly. How do I... Andrew K. Where am I? Okay. Well, it totally makes sense not to overcomplicate the language and just to play devil's advocate here. If we take the assumption that self-documenting code is good scene, then I think it's safe to assume that if the intent is to be C evolved, then it's okay to introduce a couple new concepts. Not need to go all C++ Rust on it and ruin the vibe. So when we be jamming. So if keeping is simple is the way, then perhaps we can make the secondary option official, where we rely on naming conventions. Okay, like with underscore decorating private. I'm curious what Andrew Kelly says. Okay, I got a bunch of new messages. Class completed. If you find the time, could you provide a short explanation for why this was closed? Or link this was already discussed somewhere else, since this is something that ZIG does differently from other languages that may come up again in the future, so it might be good to have findable official position on this issue. Here's my reasoning. There are many properties that can be leaked into the public interface of an API. For example, size, alignment of struct, performance characteristics of given function implementation, whether a function can be executed at comp time, existence, not existence of declarations, and more. It is up to the documentation of a given package to specify what exactly the major version is protecting. Alright. That is, what exactly counts as breaking and what does not. Whether a given field is part of the public API or not is one more item in the list. Of course, most of these have general recommendations for defaults. Okay, I mean, I'm not sure about this one, but okay. This alignment of type no. Performance characteristic of function no. Whether a function can be executed at compile and comp time unclear. Existence of declaration and its type yes. The idea of private fields and getter-setters methods was popularized by Java, but it's an anti-pattern. Fields are there, they exist, there is a data that underpins any abstraction. My recommendation is to name fields carefully and leave them as part of the public API, carefully documenting what they do. A good example is field protected by mutex. This field must be accessed only when mutex is held. Okay, that's... I don't know how do I feel about that. It feels bad. But also it simplifies things, right? I don't know. In this case, the field name unprotected counter properly communicates the danger of using the field without using any abstraction. However, it being public also allows proper abstractions to be built. Okay, that's a good argument actually. If the ones provided are not enough. For example, if it could only be accessed via get counter like this. Okay. Then, if the API user held the mutex for some other reason, get counter would actually deadlock. Or rely on a silly hack such as recursive mutexes. The API user needs the ability to interface with abstractions. Okay. In my subjective experience, public fields generally lead to better abstractions by eliminating the temptation to attempt full encapsulation. Okay, that's interesting take. That's actually interesting take. I mean, it kinda makes sense actually. I never thought about that, but it's actually like I guess the only thing you can do is just don't be stupid and don't use protected fields, right? But when you need them, like there is nothing you can do if they are protected. And here, like you can do anything you want. But the more effective search, is to provide composable abstraction layers. The bottom line here is that private fields is an addition to the language, making it more complicated and requiring the language to answer a bunch of questions that otherwise would not exist. Okay, not only does the feature does not provide enough value to manage the language complexity, I contend that it actively leads towards source code. Okay, fair. It's pretty fair actually. It's pretty interesting standpoint. Standpoint? No, it's point of view, right? It's proper to say point of view. I understand your reasoning and agree with it. On the other hand, it's not clear, is it safe? Is this intended allowed to access struct fields directly, as they can be unprotected? I would propose to have private public fields so they can be accessed accidentally, but not hiding private fields from accessing completely. If you really need, you can. This is how it would done in TypeScript with object field syntax, which means hey, I know that what I'm doing. Okay, interesting. I agree that adding an escape hash as a reminder this issue is closed. Good one, a good one. That was a good one. I agree that adding an escape hash is a proper answer to the concern that interface will become too locked down and uncomposable. This solution was already suggested in this thread though, in form of len, using built-in for these multiple advantages such as not requiring new syntax or being easier to search for private field. The additional robustity may also be seen as benefit since overriding visibility is not to be used casually. Private fields would have made this memory leak harder to happen, maybe prevented. Hive put. Okay. Okay, that's interesting. That's the creator of ban, right? Yep. Jared Summer. I still think a private field is a good idea. Okay. It's not planned. Okay, so there are just no private fields, okay? There are just no private fields. Let's leave it at that, okay. What was I doing? Game cells. I have to print it. I have to print them. So I can just access them, right? I can just take it. But how do I print them? I have to convert it to canvas, right? Oh, okay. Okay, I guess I know how. I'm gonna init it, right? Yeah, I want it to be canvas, like, I really want it to be canvas. Maybe make it canvas, then. Okay, actually, like, I don't feel like thinking today. I'll leave it for tomorrow.